Please welcome to the stage Gabriele Columbro, Executive Director of FinTech Open Source Foundation and General Manager of Linux Foundation Europe.
Hear me? Hola, buenos días a todos. ¿Qué tal estamos? Oh, wait, they're telling me I gotta do this in English. Okay, how are you guys today? I'm so excited to be here. I hope you are as well. I'm Gabriele Columbro. If you guys were expecting Jim, sorry, you got me today. We have a super exciting program this week. I'm really, really excited to be here. So before we get started with our program, I have a few housekeeping announcements that I'm going to go through, and then we can get started. So first of all, I want to thank our diamond sponsors for the conference. Thank you to Google, Fujitsu, and our friends at openEuler. We really appreciate your support. We couldn't be doing this without you. As well as our platinum sponsor for the conference. It's really great to be in this amazing venue, and again, this wouldn't be possible with all of our sponsors. So thank you so much to everyone who sponsored the conference. So I'm going to bring in our first keynote speaker. I want to introduce today Xinwei Hu, who is the Technical Committee Chair of the openEuler community. Xinwei served as chairman for the openEuler Technical Committee and is responsible for the overall technical direction and management of their community. Today, we'll share more of openEuler, a talk about ushering the future of intelligent, diversified computing. Please help me welcoming Xinwei Hu.
Morning, everyone. Hola. It's my pleasure to be here. My name is Xinwei Hu. I'm the chair of Technical Committee of openEuler community. It's really nice to be here to see all these old good friends. And for today, I'm going to introduce openEuler, what we are working on for a future of intelligent and diversified computing. So a lot of things happen in the industry in the past few years. We see a lot of new hardware technologies emerging. Especially the rising of domain-specific architecture is quite attractive to all of us. And also, we see a lot of new application demands because AI has made huge success, and that really impacts almost every area, from the Internet of Everything to the industrial transformation. So we see that the diversified computing era has arrived. What we need is a platform to support all these versatile scenarios. And also, we need a platform to be able to the innovation engine to support and implement all these new requirements from both hardware and application. And that's the reason, that's why we start to build openEuler. openEuler is an open source operating system to support both versatile application and diversified devices. From the application's point of view, we almost cover all these mainstream scenarios. We support CRM and ERP application from the information technology point of view. We support OSS and NFV, if you're familiar with that, from the communication technology. And we even support DCS, SCADA, and PLC from the operational technology. That's mostly about industrial manufacturing. And we support all these mainstream applications from AI to cloud native to big data, etc. So that's from the application. And for the hardware, we covering all these diversified devices. We support all these mainstream CPU architectures, including x86 and ARM. And also, we support emerging hardwares, including RISC-V and Longshan from China as well. And we support quite a lot of types of servers and boards. But what really makes openEuler different from other OS, we think, is our goal to make a OS for diversified and intelligent computing in all scenarios. Why does that matter? Well, we'll talk about that a little bit more details. First, why the diversified computing really matters. We think because the world of everything smart needs that. With the very rapid development of AI technology and the Internet of Everything, we already see the demands of computing power is growing very fastly. People estimated that in 2030, the global general computing power will reach 3.3 zettaflops. Well, that's about 10-fold increase over 2020. And the global AI computing power will increase even faster. That estimate is about 105 zettaflops in 2030, which is a 500-fold increase over 2020. And besides this rapid increase of computing power requirements, we also see that different computing tasks actually requires different computing powers. We use CPU for the general computing, and we usually use NPU or GPU for the AI computing, and sometimes we use DPU for the data processing line. And everything sounds fine, sounds good, but we actually see some shadows casting upon that, because the utilization of computing power in today's data center is already very low. In a typical data center, we see about half of the computing power is actually wasted on CPU already. And the diversified computing power will make things even worse because of various reasons. And that creates a dilemma that, for one hand, we want to have much more computing powers to achieve the bright future about world of everything smart. But on the other hand, because of the low utilization of the computing power, make the sustainable development dim, and it's hard to achieve that bright future. And so we think this is a challenge the industry faces. And this is also a challenge for us to reach the carbon peak in 2030 and the carbon neutrality in the future. And we also think operating system can play an important role here to solve this challenge for the future. Why is that? Because we see the challenge and opportunity in both memory, in scheduler, and also in management. Let's take memory, for example. For today's GPU and NPU, if you look into the software stack, you can aware that the device driver takes the responsibility to manage the memory inside the device, right? And the application developer's responsibility to manage the data movement between the devices. And we actually think they don't doing well. And memory management is actually too important to be managed by these individual developers. So the idea is that we think the operating system should step forward and manage and unifiedly manage all these heterogeneous memory of all these heterogeneous devices. So our idea is called GMAM. The proposal is called GMAM, and there'll be a separate technical talk late this afternoon. We see a lot of improvement by leveraging this technology. So the device drivers and application developers don't have to reinvent the wheel again and again for the slightly different customized scenarios in the diversified computing. And you're welcome to join us and see if we can improve this proposal altogether. So that's about memory. And if you look into the scheduler, you can find something very similar. It's not easy to share the diversified computing power across different tasks, especially when the tasks have the different priority. And the idea, so we're still mocking up, and we don't have a solid solution, but we think the idea is to make a collaborative scheduler between all these diversified schedulers so that you can have a preemptive scheduler across these diversified computing powers, and you can even migrate your tasks among all these computing powers. So that's about scheduler, and we want to make it more efficient. And then about management, we see a lot of work in the community already working on that too. And for openEuler, we currently have a special interest group working on DPU already. We want to provide a unified interface for various small DPU devices in China market. And by doing that, we are able to create pools out of these devices, and by pooling, it's able to achieve a totally higher utilization of all these devices. So to all, our idea is we think for the diversified computing in the future, what we really need is a converged OS. So OS will not manage these diversified computing devices as separate devices anymore. Instead, we want to unify them, to converge them all together into one, so that operating system can manage, can allocate resource, can schedule across them from the global point of view. And by doing that, we are able to improving the computing power utilization and also reducing the computing power waste, and to achieve a better future for us all. So the second, why we really need an OS for all scenarios that have been asked a lot of times when we start to announce that. And we want to make clear that it does not mean that openEuler provides a single operating system instance to running everywhere. Instead, we actually is a OS platform to be able to create OS for all these different scenarios, from cloud to edge to embedded. And that gets some obvious beneficial for us. First of all, by improving the toolbox of openEuler, we're able to combine and tailor the software components on demand, and be able to combination on demand that we can actually sharing technologies across cloud, edge, and embedded. That also means if you port a feature to the cloud, then you can automatically benefit on the edge and even on the embedded as well. So the technology sharing is a good thing for us. And we actually see something even better, because the boundary between the cloud and edge is already very blurred in today's industry, and that happens as well on the edge and embedded. And when we root all the OS into one single platform, that we're able to interwork in the ecosystem of embedded, edge, and cloud. That also means if you develop an application for the openEuler embedded version, the embedded instance, that application can migrate to run on the edge with no problem, and even migrate to the cloud. So that's about ecosystem interworking. And also, because we all share the operating system kernel, it's a way to vastly simplify the interconnection between the edge and embedded. And we see a lot of good things happen there, too. So our idea is that OS for all scenarios really makes the cross-domain innovation easier. And that cross-domain innovation really helps us to get to the future for the all things smart. And then last but not least is about what we need OS for the future of intelligence. What we think is operating system for the future of intelligence really need to be with AI, for AI, and by the AI. So what do you mean? So for nowadays, openEuler start to support, operate, and manage but with AI. We just developed a new shell called openEuler Copilot to connect the large language model to your system administrator daily work. So by using openEuler Copilot, the system admin can just use a chat-style language to ask the Copilot to collect information, to analyze and fine-tune the system, and the Copilot itself be able to generate scripts and be able to run the scripts by the permission of system administrator, and then can analyze the system bottleneck and fine-tune the kernel setting or system parameters. And after all, we can achieve the system running on openEuler have a better throughput, a lower latency, use less hardware resource, and best of all, always stay up to date. So that's about with AI. And openEuler is also ready and optimized for AI. We're going to integrate Llama and ChatGLM, for example, into the release of the community distribution directory. And also, we will try some out-of-tree features, as mentioned, like, for example, GMAM, integrate into the openEuler to make AI application running better. And also, openEuler's assisted build and test by AI. For example, on the compiler side, the Bishan compiler is an LLVM-based one. It's trying ways to replace the heuristic algorithm with AI model to provide a smaller and faster binaries for openEuler. And also, we leverage AI for the fast testing. And we use large language model to generate testing models, which can help to get a better software quality. And also, these testing results will get feedback to the upstream community to benefit a wider community. So, as mentioned, that for openEuler, we're working on the diversified, intelligent in all scenarios. But back to the foundation, we're still an open source project. openEuler is not built from nothing. We actually built based upon the successfulness of a lot of open source projects. And openEuler itself is an open project, is a community project. When we started openEuler about 3 years ago, we count the daily active developer is about 311. And nowadays, when we count the daily active developers, it has been increased for about 300 to 4,000, almost 4,000. That's about 10 times in 3 years, which is an awesome result. And with the contribution of all these developers and also the users even more users beyond counting that our community is able to generate about more than 100 pull requests per day. The packages directly integrated into openEuler increase about 30 every day. And for every month, there are about 10 newly charted projects inside the community, and we release more than 80 bug fix updates to the community every month. So we all understand that community development and innovation is a quite long run process, and all these numbers cannot be achieved without the help, without the continuing hard working of everyone. And because of this contribution, we can see that openEuler has already become a dynamic and innovative community. We have a lot of incubated projects inside the community. Well, we don't have time to go through all of them, but just name a few. Like, for example, you can see Mika. Mika is our project to co-deploy a real-time OS together with a non-real-time OS on a single multi-core SoC. Well, it's kind of mouthful, but that's the trend of the industry today. And also, you can see the software bus. Software bus is a way to auto-discover and communication for the devices on the edge. We learned that idea from today's smartphone and wearable IoT scenarios, but when we implemented for openEuler, we found that's really, really helpful for the industry. Okay, there are so many other incubated projects. We can't go through all of them, but we consolidated a white paper in English to introduce all of them, so you can find one paper on our website nowadays. And we also want to emphasize that openEuler is not just a technical preview. We also very, very focused on landing these technologies in real scenarios. For the community members, we already have more than 1,100 community members, and all these members, they join the community, and they use openEuler as a base OS for their daily work. And the installation base for openEuler already reached more than 4.5 million. That also means openEuler is being evaluated and verified in a lot of scenarios, including carrier, finance, public facility, and even powers. So, given this widely adoption, we have the confidence that openEuler is gaining momentum, and we also have the confidence that openEuler can be even more widely adopted. So that concludes my talk. Thank you very much, and you're very welcome to join our community to work together on an OS for the future, for the diversified and intelligent computing in all scenarios, and you can learn more about us on booth D1. Thank you very much.